If you were to walk north of the Arctic Circle in mid-January into the vast, frozen expanse of Sapmi, the land of the Sami people, you would enter a world where biology stops. The sun does not rise for weeks. The temperature hovers at 30, sometimes 40 degrees below zero. At this temperature, the fluid in your eyes begins to thicken. Metal burns your skin on contact. The silence is absolute, broken only by the sound of your own heart struggling to pump blood to your extremities. In this landscape, you are a tropical animal in a cryogenic freezer. To stop moving is to die. But the Sami people do not just survive here, they follow the rhythm of the reindeer. They are nomads. They cannot build thick stone walls or dig deep underground bunkers because the reindeer move, and so must they. They have to pack their entire lives onto sleds and move across the tundra in minutes. This creates a terrifying paradox. To survive the killing cold, you need a fortress, but to follow the herd, you need a tent. Common logic tells us that a tent is a flimsy thing, a piece of cloth that flaps in the wind and offers zero insulation. If you took a modern nylon mountaineering tent into a Sami winter storm, the condensation from your breath would freeze on the walls, turning the inside into an ice coffin. If you tried to light a fire inside to stay warm, you would burn the tent down or die of carbon monoxide poisoning within the hour. Yet, for thousands of years, the Sami have slept soundly in the middle of blizzards, warm and safe, inside a structure that defies modern architectural logic. They built a mobile chimney that anchors itself to the ground using the very force that tries to destroy it. To understand the genius of the Lavvu, you must first understand the specific violence of the Arctic environment. The enemy here is not just the cold. It is the combination of the wind and the snow load. The winds on the open tundra are katabatic, gravity-driven avalanches of air that pour down from the mountains. They don't just blow, they shear. A wall with a flat surface acts like a sail. The wind pressure builds up until the structure snaps or is ripped from the earth. Then there is the snow. In the Arctic, it doesn't always snow heavily, but the wind drifts the snow. A structure can be buried under tons of white weight in a single night. A flat roof would collapse, a dome would be crushed. And finally, the most insidious enemy, moisture. When a human sleeps in the cold, they exhale moisture. In a sealed modern environment, this moisture condenses and freezes. Damp clothing in the Arctic leads to hypothermia faster than nakedness. You need heat, you need a fire. But a fire in a small enclosed space creates smoke. The Sami were trapped between freezing to death or suffocating. They needed a design that was aerodynamic enough to cheat the wind, strong enough to hold a mountain of snow, and engineered to manage fluid dynamics so perfectly that smoke would rise while heat stayed down. Imagine the first struggles of the ancestors of the North. Before the perfection of the Lavvu, the trial and error must have been agonizing. You can imagine a family trying to build a simple lean-to or a conical hut using straight poles tied together with rawhide. The wind screams across the tundra. The rawhide freezes and becomes brittle. The knot slips, the poles slide apart. The structure collapses in the dark, burying the occupants in heavy hides and freezing snow. The sensory experience of a failed shelter is the smell of fear and soot. You try to light a fire, but the wind blows down through the smoke hole, filling the tent with blinding, choking smoke. You are coughing, eyes streaming, forced to open the door flap to breathe, which lets in the lethal cold. It is a choice between the lungs and the limbs. They realized that using rope or rawhide to secure the main frame was a point of failure. Ropes rot. Knots freeze. They needed a connection that was mechanical, something that used gravity instead of fighting it. The turning point, the engineering breakthrough that defined the Sami culture, was the discovery of the forked pole. This sounds simple, but it is a stroke of geometric genius. Unlike the Native American Tipi, which often uses a four-pole base tied with rope, the Sami Lavvu begins with 3 specific poles. These are not just straight sticks. They are carefully selected birch trees that have a natural, strong fork at the top. When these three forked poles are interlocked, they form a tripod. This is the strongest geometric shape in nature. The forks lock into each other. There is no rope. There is no knot. Gravity pulls them down and the forks jam together. The more weight you put on them, the heavier the hides, the deeper the snow, the tighter the lock becomes. This frame is self-tensioning. But the structural innovation went deeper. They realized that birch wood, Betula pubescens, has a unique property. It is flexible. In the extreme cold, pine or spruce can become brittle and snap under a sudden wind gust. Birch bends. When the gale hits the lavvu, the poles flex slightly, absorbing the kinetic energy of the wind like a spring, transferring the load into the ground rather than fighting it rigidly. But discovering the frame was the easy part. Making the tent livable required mastering the invisible flow of air. The construction of the lavvu is a tactile ritual. It begins with finding the right ground. You don't just pitch it anywhere, you look for a slight rise to let the cold air sink away. You gather the poles. You can feel the weight of the seasoned birch, dense, smooth, and pale. You set the three forked poles first. They click together with a satisfying, dull wooden thud. Then you lean the straight poles against this tripod. There are usually 12 to 15 poles in total. The angle is critical. It is not as steep as a tipi. The lavvu is squatter, wider at the base. This lower center of gravity is crucial for wind resistance. It hugs the earth. Then comes the cover. Traditionally, this was made of reindeer hides sewn together with sinew. Today, it might be heavy wool or canvas, but the principle remains. You wrap the cover around the poles. It is heavy. It smells of smoke and lanolin. You don't stake it down with pegs like a camping tent. That would be impossible in the frozen permafrost. Instead, you pile snow and birch branches around the bottom edge. This skirt seals the tent to the ground and adds weight. But then the crisis hits. The polar night descends. A blizzard rolls in from the Barents Sea. The wind speed hits 80 miles per hour. The visibility drops to zero. The world outside becomes a white void of screaming ice. The snow begins to pile up against the side of the tent. In a normal building, this uneven loading would be catastrophic. The pressure on the windward side would push the wall in. But the lavvu is a cone. A cone is an aerodynamic miracle. The wind doesn't hit a flat wall. It splits and flows around the curve. As the wind speeds up around the sides, it creates a low-pressure zone that actually sucks the fabric tight against the poles. But the craziest thing is, the stronger the wind blew, the safer the structure became. The wind piling the snow against the skirt of the tent added mass. It anchored the poles deeper into the snowpack. The storm was literally building a foundation for the house it was trying to destroy. Inside, the engineering shifts from structural to thermodynamic. You light the fire in the center. In a wooden house, the smoke would fill the room. But the lavvu is a machine designed to control the stack effect. The shape of the tent creates a natural funnel. The heat from the fire rises straight up to the open smoke hole at the apex, called the reachpen. As the hot air and smoke rush up and out, they create a vacuum. This vacuum pulls fresh air in. But where does the fresh air come from? The Sami leave the door flap slightly loose or use an air intake log at the base. The cold, oxygen-rich air enters at the bottom. It is heavy, so it stays low. It feeds the fire. The fire heats it and it rises. This creates a continuous, invisible toroid of airflow. The smoke is carried up a column of heat in the center. Surrounding this column of rising heat is the living space. The slanted walls reflect the radiant heat of the fire back down onto the people. The reindeer hides on the floor, insulate against the frozen ground. The result is a microclimate. Outside, it is -40. At the peak of the tent, the smoke is exiting. But at the sleeping level, it is a comfortable 10 or 15 degrees Celsius. The test of survival is the long night. The storm rages for 3 days. You cannot leave. If the fire goes out, you freeze. If the smoke doesn't draw, you choke. But the Lavvu holds. The tripod lock does not slip. The birch poles groan and flex, but they do not shatter. The contrast between the chaos outside and the calm inside is profound. Inside the Lavvu, there is a social hierarchy mapped onto the floor plan. The back of the tent, the boshu, is sacred. No one steps over it. It is the direct line to the spirits. The door is the profane world. The fire is the mediator. The family sits on the springy birch twigs covered in furs, drinking coffee, repairing tools. They are sitting inside a chimney that is also a home. The result of this design is thousands of years of cultural continuity. The Lavvu allowed the Sami to exist in a symbiotic relationship with the reindeer. They could arrive at a new pasture and within 30 minutes have a warm, safe home erected. When the herd moved, the home vanished, leaving no scar on the landscape, only a circle of trampled snow. Data from modern thermal imaging shows the brilliance of the design. The cone shape minimizes the surface area exposed to the cold relative to the volume inside. The smoke bell effect keeps the warmest air right at the sitting level before it cools and exits, and the load capacity of the tripod frame can support the weight of a grown man hanging from the center or a meter of wet snow without buckling. The Sami Lavvu is a masterclass in adaptation. It teaches us that resilience isn't about resisting nature with brute force, it's about geometry and flow. The Sami didn't build walls to block the wind. They built a shape that let the wind pass. They didn't build a chimney of brick. They built a chimney of air. In a world where we rely on thermostats and complex HVAC systems that break down, the Lavvu reminds us that simple physics-based solutions are often the most enduring. It is a shelter that requires nothing but the forest and the knowledge of how to put it together. If you want to discover more forgotten ancient technologies that helped humanity survive, subscribe now and comment below. What type of ancient shelter should we explore next?